Howdy guys, my name is Maribel and for today I will be doing problem 4 from our ECEN 350 final. Alright, let's get to it. Consider the jump register instruction. What would have to be added to this data path to support this instruction? Draw in the figure below any extra logic or control lines needed and write a short description of how they would work. Indicate the values for all control signals, including any we add, when the jump register instruction is executed. Be sure to mark unused control signals with an X. Now, just keep in mind that X means don't care for future use. Alright, I went ahead and wrote what the jump register does. It's just jumping to the address contained in the register S in this case scenario. Okay, to get started, let's go ahead and start with our control signals listed below, and I'll explain as I go. For the first one, register destination must be an X. The reason why is because we're just jumping to whatever the register is. It doesn't care whether we put anything into it because we're not storing anything in a register. Next, branch must be 0 in this instruction. It's pretty straightforward. Because we're not branching anywhere in this instruction, it has to be 0. And because we're definitely not writing to a register, our reg write must be 0 in this case as well. A quick explanation I'm going to throw out there is this mux input right here. Okay, this mux input wouldn't matter because it's not being used anyway, nor would its inputs over here. Alright, next, ALU op and ALU source. Now, since the register file isn't being written to and the data memory is neither being written to nor read from, then ALU has no operation to perform in this case, so it doesn't matter. So let's go ahead and set those to don't cares. Alright. Now, from what I said on the part that data memory is neither being written to nor read from, this means memory is equal to 0. Next, mem to reg. Funny thing, mem to reg is an X. This is because regardless of what the value at this line is that's going into write data, follow the mouse below over here. Alright, because regardless of what the value is at this line, the register file doesn't have anything being written to it, so it doesn't matter what's on the line. Now that we have all these control signals done with, let's see how we have to modify our data path. So for jump register, we know we're jumping to the value that's stored at a given register. So instead of pulling the data from before the register file, we have to pull it from after the outputs of this register file I'm circling from. Now, whether we pull it from read data 1 or read data 2, I will show you right now. Okay, take a look at our MIPS data sheet. Jump register. It says we're going to the register RS, right? We're pulling from the register RS. So it's this top line up here from read data 1. Right here, the output of read data 1. As you can tell, I've already pulled my data path from here. Alright. And I went ahead and created a mux. The reason is because we can't put this data path directly back into PC because then we wouldn't be able to do any of the other instructions that would require us to increment by 4. So we'd actually have to create this mux that I added here. As long as it's right after this old mux, we're good. Now, one of the inputs we must take, of course, from our read data 1 that we pulled from, and the next input we take from the output of this old mux. So basically, it would choose between which one to read, so that way you could still increment PC by 4. You could still branch, or in this case, still do the jump register instruction here. It would just depend on what the control signals were set to. With that being said, this control signal, let's call it jump reg. And since our input coming out from read data 1 is attached to the 1, we have to set it to 1 in order to complete this instruction. All right. With that said, we must create that new control signal, and we set it to 1. As long as we take the output of this mux and put it back directly into our PC right after it, it should be executed correctly. Now for the short description below, the question asked us to write a short description of how the control line and the extra logic would work. So, like I said before, because our data path pulling from read data 1 is attached from it's attached to the 1 in our mux, and we want to execute the jump register instruction, then we must set jump reg equal to 1. Alrighty, this basically sums up this question. So, not too bad, huh?